Okay, so I am going to teach you this material by this video, and then I'll go over it once I'm done. So this unit, or this part of this unit, is measurement, significant figures, and scientific notation. So the first thing that we have to look at is the two types of observation that we can have. Hold on, let me add that. Okay, so you have two types of measurement that you can have. So all measurement is a type of observation. So you can observe the quality of things, and you can also observe the quantity of something. So we have qualitative and we have quantitative. So qualitative is just what it says. You're talking about the quality. So that is not numbers. There will be no numbers. It's just a description, like a physical description. So say if that bug was furry or smooth, or you can look at a button and be like what color it is. Okay, all of that is a physical description by not using any type of numbers. Qualitative is when we get into the numbers. So if you're talking about maybe we're talking about the purity of something. So up here in qualitative, we might say it's impure. But in quantitative, we could say something like it's 80% pure. So this would be a quantitative because we have a number. And in this case, your percent is your unit. But say if I want to weigh out 25 kilograms. So that right there is a quantitative because I have a number and I have a unit. Okay, so the next part is accuracy and precision. So a lot of times this is easiest to understand if we think of it as if you are shooting a gun or shooting at a target. And so if you're shooting darts even, it could be something like that. So if this is our target and this is our bullseye, let's analyze what it would look like to be accurate. Accurate hits the bullseye at least once, okay? So it hits the bullseye. Now, accurate does not have to hit the bullseye every time. This is also accurate, all right? But you see how far apart all the pieces are. They're really far apart. That makes it not precise, okay? So precision is when you hit in a certain spot many times. So we would call that grouping. So our grouping is really small. So there, your precision does not have to even hit the bullseye. So this one's precise. This one is precise. And this one is accurate. We can also have both and we can have neither. So let's look at this right here. So accurate, so in this column right here, both of these are accurate, right? Because I hit the center at least once, all right? And then if you look in this column, these are precise. So this one is precise and accurate, whereas this one is just precise. So it can be precise without being accurate. So if we are going to label these, this one would be both because it hit the center and the grouping is small. So this one's accurate and precise. This one is not on target, but it is very close together. So this is just precise, right? This one down here is accurate. It did hit the target right there. So this one is accurate. But the grouping is not good, so it's not precise. And then over here, the grouping is far apart. It did not hit the center, so this one is neither. So we're going to do the same thing with numbers. So when we are using numbers, you have to have some type of measurement that is your goal. And this one, it shows us that your goal is 68.1. Okay, the correct measurement is how you saw that this is the goal. Sometimes this says accepted. It can say, or sometimes it says true. Just something to indicate that that is our goal. So we're going to look at all of these examples and we're going to figure out which ones are accurate, which ones are precise, which ones are both, and which ones are neither. So let's look at the first one. 78.9, is that close to 68.1? No. 43.9, is that close to 68.1? No. and neither is 2. So this one is not accurate. But are they close to each other? No. So it's also not precise. So this one is neither. Okay. What about the next one? 98.0, is that close to 68.2? And it is not. 98.2 is also not close to this 68.1. And 97.9 is not close to it either. So this one is not accurate. But are they close to each other? Yes, they're all very close to each other. So this one is precise. All right, let's look at number 3. So number 3, 68.1, that hits on target. 68.2, that's really close. 68.0, that's really close. So this one is accurate. And are they close to each other? This one is also precise. Sorry, you can't see this color. So this is both. Okay. Now let's look at number 4. Let's use this one. Number 4, 78.2, is that 68.1? No. 60.3, is that 68.1? No, that's not close enough. What about 68.1? That one is accurate. Okay, so this is enough to make this whole set of numbers accurate. Now, are they close to each other? No, they're not close enough. So this one is just accurate. If I can spell. Okay, and so those are the answers. Okay, so that's stuff that you've probably already learned before, but let's get into something that you're not familiar with. So the next thing that we're going to talk about is significant figures. We use significant figures just to figure out which numbers are accurate enough to count, which ones matter. When we come down to the final answer, which ones matter. So the first thing that you have to determine is how to determine if something is significant. So we need to figure out, if we're looking at a number, which one of those numbers are significant and which ones are not. So we have a rule for that, or a system. We have a dot left, not right system. So what you do is if it has a dot, the decimal is the dot. If it has a dot, you take your left hand and you swipe across your face. And you stop when you get to the first non-zero. And you count everything you did not cover. Okay? If it does not, then it does not have a decimal, no decimal. You take your right hand and you do the same thing. You swipe across your face and you stop when you get to the first non-zero. And you count everything you did not cover. So let's look at this. So here's the first one. Does this one have a dot? Yes, right there you see it has a decimal. So what you're going to do is you're going to take your left hand and you're going to, so this is your left hand over here, and you're going to swipe across the screen until you get to the first non-zero. Well, you have to stop right here because 2 is not a 0. And so you did not cover anything up. So everything you did not cover counts. So all of these count. So I have 1, 2, 3, 4. I have 4 sig figs. Okay. Now look at this one. Does this one have a dot? Yes, we see a dot right there. Okay, so that means you take your left hand and you swipe across. That's ugly, sorry. You take your left hand and you swipe across until you get to the first non-zero. So these are zeros, so you keep going until you get to that 7. Okay, so all these are covered up and you only see the 7, 0. So in this one, you have 2 sig figs. Okay, let's look at this one. Okay, does this one have a dot? Do you see a dot? No, there's no decimal. So you take your right hand and you swipe across your face. Okay, hold on. I don't know why it's doing that. I don't know what it's doing. Okay. All right. So it does not. So you take your right hand and you swipe across your face. So you're going to cover it up until you get to the first non-zero. So you're going to stop right there. Okay. So that means these are significant. There are 3 numbers there. 1, 2, 3. So you have 3 sig figs. All right, next. All right, does this one have a dot? It does not. There is no dot. So what hand do you use? Not right. So you use your right hand. If it does not have a dot, you use your right hand. You start and go across your face, and you stop at the first non-zero. Well, you have to stop right there. So that means all of these count. So I have 1, 2, 3, 4, 5, 6 sig figs. All right, so let's do some more practice. So let's do number 1. It has a dot right here. So I start with my left hand because it has a dot, and I'm going to swipe across. I got to stop because that 2 is a non-zero. So I count all of them. Well, there's 1, 2, 3, 4 numbers. So I put 4. What about this one? So on this one, is there a dot? Yes. So dot left. You start over here and you go across until you get to the first non-zero. And then you count the ones you can still see. So there's 2 numbers. What about number 3? Do you see a dot? No. So you go right. So you put right, and you're going to swipe across your face, swipe across, until you get to the first non-zero. So that stops you at the 2. So then you only have 3 numbers showing. Number 4 is easy. There's a dot, yes, but there's no zeros. If there's no zeros, you can just say all of them count. Okay, that's a 4. All right, I want you to stop the video. I want you to stop the video and do the rest of them. So stop and do the rest. I'm going to write in the answers, but try to do them before I write them in. Okay, I hope that you stopped and did them, and now you're looking at the answers. So check those out, make sure that you got them right. Okay, so when we're oftentimes not just given a number, we have to figure out from our calculations how many sig figs our answer should have. So a lot of times this comes into when you put something in your calculator and it gives you have a decimal and it gives you all these numbers and you don't know where to round. This is what tells you where to round. So there are different rules. For multiplication and division, you're going to look at the pieces. You're going to look at the pieces that have been added or multiplied together. And whichever one has the fewest number of sig figs, your product or quotient will have that same number of sig figs. So you will find the number in the problem with the lowest number and round your answer to that many sig figs. Okay? For addition and subtraction, it's a little different. Addition and subtraction is a little different. You're going to look at the pieces. You're going to look at what you're adding or subtracting, and you're going to find the one with the lowest amount of numbers after the decimal. Okay? So whichever one has the lowest number after the decimal, your answer will have that many numbers after the decimal as the least amount. It'll make more sense whenever I do some. All right, so here is one with multiplication and division. So it's already written here, but we're going to go through it. So this is multiplying. So when we're multiplying, we're looking at how many sig figs total. So right here, we have 3 sig figs. Right here, we have 5, and here we only have 2. So your answer, if you put it in your calculator, you get this big old number, okay? But you need to know where to round. So since you have 3, 5, and 2, 2's our winner. 2's our winner. So that means that we're going to go over here and we're going to stop at only 2 sig figs. So we're going to stop and round to 45. All right, when you're adding and subtracting, sometimes this helps you, like this vertical line, but let me just explain it. So if I'm saying 4.8 minus 3.965, and I put that in my calculator, it gives me 0.835. All right, but where do I round? So on subtraction or addition, you look after the decimal. So this one has 1 and this one has 3. So your answer has to stop at 1. So your answer would be 0.8. Okay, same thing right here. I have 5.74 plus 0.823 plus 2.651. Okay, if I put that in my calculator, I get 9.214. But where do I round? Well, this one, remember, I'm adding. So I want to look after the decimal only. Okay, so in this one, I have 2. Here I have 3, and here I have 3. So my answer should have how many after the decimal? 2. So your answer will be 9.12. Okay. All right, so when you're doing combined calculations, you're going to follow that rule that you learned when you were young about the parentheses and everything and like which one comes first. But the main thing that we have to learn is do not round until the end. So whatever you do, you want to figure out how many sig figs you need, but you don't want to round until you're absolutely done. So in this problem right here, we have parentheses. So the parentheses come first. So we have to do this part first. Okay, so here it is, 5.67 minus 2.3. Well, I'm subtracting, so I have to look after the decimal. This one has 2, this one has 1. So right here, I didn't round. Notice I kept 3.37, but I underlined the 3.3 because that is where this section tells me to round. So I'm going to remember these are significant. All right, and then I'm going to take, I don't know why it keeps messing up on me. Sorry, y'all, hold on. All right, so I'm going to take this number, I'm going to take the 3.37, and I'm going to put it back where the parentheses were. So I have 3.489 times 3.37. All right, so what I know right now is I put it in my calculator and I get this whole answer out. Well, when we're multiplying, we need the least number of sig figs total. So right here, we have 4. And remember, here we only have 2 because these are the only 2 that were significant. So that means that my answer can only have 2. So I'm sorry I did that wrong. So my answer, if it's 11.758, I can only have 2 sig figs. So my answer is 12. Okay. Let's do some examples. These examples are going to be easier the more we do them. I went ahead and wrote them here. So in example 1, I'm multiplying. I have 4.5 times 0.03060 times 0.3914. All right, lots of numbers. I put that in my calculator and I get this big old number out. This is what my calculator gives me. But how do I know where to round? Well, you go back, since you're multiplying, you look at the least number of sig figs total. So I have 2 right here, I have 4 here, and I have 4 here. So how many should my answer have? 2. It has to have the least. So I'm going to start here and I'm going to go all the way to the 5, 3. These zeros, remember, are not significant because I have a dot. So this is where I need to stop. Okay, so my answer will be 0.054. We'll talk about that 4 in this whole rounding situation later. So in example number 2, I'm saying 5.55 divided by 8.97. Okay, if I put it in my calculator, I get this big number. Well, we're dividing. The rule for division is to take the least number of sig figs. So this one has 3 and this one has 3. Okay, so that's pretty easy. Your answer has to have 3. So I'm going to draw my line until I get to the third sig fig. So this is what I keep. So my answer is 0.619. All right, next. Okay, so this one, most of the time, I realize up here, you're not going to separate it and do all this stuff, because we put it in our calculator. So let me show you if you put it in your calculator how you would do this. All right, so if you put this in the calculator, make sure you put that in parentheses and then you divide it by the 0.0087. If you put that in the calculator, this is what it gives you. But we need to learn where to round. So we need to figure out right in our parentheses how many sig figs came out, okay? Well, this is a subtraction, so we have to stop at the first decimal. So if we do that, then we should only have like 3 sig figs, okay? This one only has 2 sig figs. So your answer can only have 2 because division is our overall process. That's what we ended up with. So 2 is the amount of sig figs you can have. So you're going to take the 2 right here. Now what happens to this 5 and 1? Can we just round this to 38? No, because this is 3,851. So we have to put those zeros there and say that it's actually this. That's our new answer because we have to only have 2 sig figs, but we can't get rid of those. We can't get rid of the idea that it was 3,000, okay? All right, let's do the next one. So in this one, we have 86.6 plus 9.888 plus 2.3 plus 10.77. All right, so the rule for this is following our addition rules. Our addition rules is to look after the decimal and see how many numbers. We'll have 1, 3, 1, 2. So my answer should have 1, right? Because that's the lowest number. So you're going to stop. You're going to keep all of these numbers and stop right there. So you're going to say 109.6. Okay? So here's your next one, 43.7 minus 2.341. So this one is subtraction. So your rule is looking after the decimal. And so you have 1 here and you have 3 here. So your answer has to stop at that 1 number after the decimal. So your answer will be 41.4. All right, so I realize that on all of this, it's probably pretty simple to do the ones that are like just multiplication, just division, just addition, or just subtraction. These are the ones that get hard whenever you have to do all the steps, like you have a subtraction and you have a division. Most of the time, if you look at your problem, you can figure it out by saying which one has the lowest number and then rounding it there. If you can't do this whole process where we looked at 3 and when we looked at the 1, or we looked at the 1 and we looked at the 3, and that gave us 3 sig figs, and we compared it to these 2 sig figs. If you can't do all that, normally the answer will be right if you just look at the whole problem and say which one has the lowest number of sig figs, and then rounding your answer to that. All right, so let's talk about rounding rules. For the most part, y'all know this. It goes, if it's less than 5, If it's less than 5, you're just going to leave everything the same. You're going to drop that number. If it's more than 5, you're going to raise the number. And if it's 5, this is where the rules kind of change. So if it's 5, you're going to make the preceding number even by either leaving it alone or raising it by 1 digit. So let's talk about the numbers I'm referring to. So when we are rounding, the only numbers we are looking at is what I call the one on the cliff and the one falling off the cliff. So let's look at what I mean by that. So here's an example. So this right here is my cliff. That's how many sig figs I can keep, these 2. So my cliff is 0.063. Those are on the cliff. The other ones, 4, 0, 6, 8, these are falling off the cliff. They didn't make the cut, all right? So the only ones we have to do anything to are the ones right on the cliff and the one right off. So we're going to look at the one that is right off the cliff. We're going to look at this 4 right here. And we're going to say it is less than 5, so it is just going to fall, and this 3 will stay the same. That's why we said leave the preceding number the same. So the answer is 0.063. Okay, let's look at the next one, 0.618729. Okay, so for this one, we decided our cliff we decided this from our math. Like if this was done, this would have been decided from your math. Like those are the significant numbers. So this is your cliff. So that means that these numbers are falling off the cliff. So the only ones that matter to you is this 7 and this 8. Okay? And so you look at the one that's falling off, this 7, and say it is more than 5. So you raise the number in front of it. So this is 0.619. That's the answer. Okay? If this 7 right here, the number falling off the cliff, this number is falling off the cliff. If it is more than 5, then you raise the number right beside the end. Okay. Okay, so let's do this one. 3851.83908. That's what the calculator gave us, but we found out we only needed 2 numbers, 2 sig figs. So this is our cliff. So that means that all of this has to fall. But remember, this is 3,851. We can't round that to just 38. We have to keep the zeros right here. So this would round to, this is a 5. 5 is what you're looking at because this one is falling off the cliff. So if it is a 5, our rule is to make the preceding number even. Okay? Well, this 8 is an even number. 8 is an even number. So we're good, right? So we just say 3800. That's a new rule for y'all. The other rounding rules you should already know, but this 3800, this whole even rule, if it's a 5, drop it and make this rule even. That is a new concept for y'all. So let's do this one. 41 point, oops, I forgot my one. 41.359. Well, we stopped here. This is our cliff. All right, so that means that these are falling off. So we look at the number that's about to fall and we say, is it less than 5, more than 5, or equal to 5? Well, it's equal to 5. So what we do is we say the preceding number, this 3, has to be even. Is 3 an even number? No, so we have to round it up. So our answer is 41.4. All right, I'm going to go back over all this in class. I just wanted you to go ahead and learn it so that we could review it. Have questions ready for me, and let's go.